Right. G'day, welcome. I might have fixed my tripod. Before I couldn't, rotate it up and down, now I can. Hopefully it doesn't fall off halfway through the stream, because it is literally hanging on by, the tiniest thing right now, so... What we're doing today is biology. Paige drew all of this, and I'm gonna have to rub it off, but... What we have been given paper 2 for 2024, and our homework is to do the paper. But before I do the paper, I want to flick through it, and I want to see if there's any things that I need to revise before giving it a go. Because I have not revised biology properly in a good couple of days now, so I might be quite far behind on some things. So... This is the paper. I don't know whether it's legal for me to show you guys the questions here. I don't know, actually, but we'll give it a go nonetheless. We'll look at these questions, figure out what we need to revise, figure out what we're fine with. Right, so... That's fine. Right. So again, this is paper 2, so this is all of the following content. Okay, first question is on synapses. No, the neuromuscular junction. Oh, okay. Okay. The figure shows a drawing of a neuromuscular junction. Name the parts. That is fine, right? We know what this is. This is some shit like this. It's asking for... What are these things here? What are these things here? What is this? And what is this? Okay, that should be fine. That is the synaptic cleft. I don't know if it has a different name because it's a neuromuscular junction though. I don't know that. But that's a synaptic cleft. That's going to be the presynaptic membrane. This is going to be neurotransmitter. Is it acetylcholine in the neuromuscular junction? Wait, no, what would they want here? Would they want you to say vesicles, or would they want you to say acetylcholine? Oh shit, what would they want you to say? I don't have a mark scheme. I don't know what they want you to say here. Oh shit, what would they want? This is a neuromuscular junction. What neurotransmitter is released? Let's have a look. I probably have it in one of my books. I probably have it in a book. Yeah. We're talking about the neuromuscular junction. Fast and slow twitch. Oh, I completely forgot about fast and slow twitch muscles. Oh my god. It doesn't specify in my book. So either I didn't write it down, or it's either. Okay. I will just take a completely... What if I put vesicle containing neurotransmitter? I'll put acetylcholine, then obviously that's for mitochondria. So, how many marks is that? 2 marks. Let's just say we got 1 mark there, because we got that wrong. Next question. Oh no. Following the... Oh, wait, it gives us the answer. Following the release of acetylcholine into a neuromuscular junction. Okay, so that's acetylcholine. A muscle contraction occurs. Describe the sequence of events that leads to stimulation. Do not include in your answer the events following the release of calcium ions. Wait, what? Describe the sequence of events following the release of acetylcholine that leads to stimulation. So everything before calcium ions. Oh my god, I don't remember. And this is 4 marks. What do you mean this is 4 marks? Following the release of acetylcholine into a neuromuscular junction. Wait, is that what it's called? No? Wait, okay. What's it wanting? What is this question wanting? What is this question wanting exactly? Because we can say that acetylcholine, the vesicles fuse with the membrane, releasing acetylcholine into the cleft. They diffuse into the, obviously they bind to the receptors. What happens after this? I don't remember. Channels open? Is it sodium channels that open? Causing an influx of sodium ions that stimulates the sarcoplasmic reticulum to release calcium ions. How are we going to get 4 marks out of that? I don't know. What does our textbook say? What are we missing? What are we missing? Oh my god. Oh my god, I don't know. I literally have no idea. Acetylcholine binds to the receptors on the muscle tissue. These receptors are located on sodium channels which open, causing depolarization of the muscle tissue, and sodium ions diffuse into muscle tissue. Oh, the T-tubules! Okay. They are extensions of the cell surface membrane that come in contact with the sarcoplasmic reticulum, which stores calcium ions. The arrival of the action potential stimulates calcium ions to open, so they diffuse out into the sarcoplasm. Okay, we can do this now. See, I forgot about T-tubules. How would you describe T-tubules? What does it specifically want me to say? Extensions of the membrane. Okay. So, we'll draw it like this. So, the acetylcholine will bind to receptors on muscle tissue. Because remember, this isn't a postsynaptic knob. This is muscle tissue. Or is there a different name for that, maybe? muscle tissue. I think you can just say muscle tissue. Okay, so acetylcholine will bind to the receptors on muscle tissue. The receptors are located on Na plus channels, which open. Na plus enters the tissue. It travels through the T tubules to sarcoplasmic reticulum, which causes CO2 plus ions to be released. I'll just put arrival of action potential, CO2 ions are released. We should also specify this hyperpolarizes. Hyperpolarizing the muscle tissue. Sodium ions travel through the T tubules to the sarcoplasmic reticulum. Let's just try and make sure we haven't made any mistakes. It binds to receptors. These receptors are located on sodium channels, which open, causing depolarization of the muscle tissue as Na plus diffuses into the muscle fibers. Depolarization travels the length of the T tubules, which are extensions of the cell surface membrane. They come in contact with the sarcoplasmic reticulum. The arrival of the action potential stimulates ions. So, could we maybe make one or two improvements? Yes. This, yeah, that's fine. Receptors cause them to open. Obviously, that will cause Na plus ions to enter and diffuse through the T tubules, through the length of the fiber. So, overall, if you were going to talk about this process, this is 4 marks. How would we get 4 marks? I think this would be 1 marking point. Binds to receptors, causing Na plus ions to open. Mark point 2 would probably be saying that Na plus ions will diffuse through the T tubules, hyperpolarizing the muscle tissue. Or I guess you could overall just say that this hyperpolarizes the tissue. The hyperpolarization will travel through the T tubules. The arrival of the action potential to the sarcoplasmic reticulum causes the release. I would probably get 3 marks for that, worst case scenario. See, this is my thought process in an exam, okay? In an exam, I am always counting how many marks I think I've got. I know that that's kind of like a running meme that people do that if they think they're cooked in exams. I always do it. I've always done that for years. I will always figure out if on a good day how many marks I would get, and if on a bad day how many marks I would get. So right now, on a good day, I would say that I get 6 out of 6. On a bad day, probably a 4 out of 6. Inhibitory synapses cause hyperpolarization. Did I say hyperpolarization before? I meant depolarization. Shit. Hyperpolarization in postsynaptic neurons. Explain how this inhibits synaptic transmission. Oh! Okay, well, it's the release of chloride ions, which are negatively charged. This hyperpolarizes the knob, the postsynaptic. Because hyperpolarization. Explain how this inhibits transmission. What the fuck? Therefore, there is no action potential can occur in the knob in postsynaptic. No action potential can occur because the charge is being rapidly decreased. So the arrival of Na plus ions can't do anything. I don't know how you would word this. Let's have a look at my revision document to see. See, odds are, my plan is, I probably am not going to do the paper today. I might do it on Wednesday, but... Neurotransmitter binds to receptors, chloride channels open, it diffuses into the neuron, hyperpolarizing by decreasing the charge, preventing an action potential from continuing to the next neuron. So that's all I wrote. No action potential can occur, and we'll just put in next neuron. Because the charge is decreased. Would that be 2 marks? I don't know. I would say maybe 1 mark, worst case scenario. Right, next. No, more muscle contraction. Shit. This is the one fucking thing I haven't ever revised. The figure shows a part of a relaxed myofibril. The myofibril, which I think is a unit of a muscle, represented has 34 sarcomeres. The length of every sarcomere is 2 micrometers. After contraction of this myofibril, the length changed. Calculate the length of a myofibril after contraction. So, what are we given? The length of the entire sarcomere is 2 micrometers. The myofibril in the figure above has 34. So already that is going to be 68 micrometers worth of... So the length of every sarcomere is 2 micrometers. The figure represented shows that there's 68 micrometers worth of myofibril. So that's the length of myofibril is 68. Okay. After contraction, the length of each sarcomere changed by 20%. So that's going to be 68 micrometers times 1.2. Do I have a calculator? No, I'm going to go grab one. I'll be just... Okay, so I just did 68 times 1.2 and I got 81.6 micrometers. Now to convert to millimeters... Oh, fuck, how do you convert from UM to MM? Is it... What? Oh no, I don't remember. Oh my god, why am I so thick? Okay. Millimeters to UM, isn't it times 1,000? So surely, if my remembering is right, you divide by 1,000. 81.6 divided by 1,000. 81.6 divided by 1,000 gets you 0.0816. In standard form, that would be 8.16 times 10 to the power of minus 2. Let's write this one down, because it's a math question. I'll do it later anyways. So, 34 times 2 is 68 is 1 myofibril. 68 times 1.2 is 81.6 UM. 81.6 UM to 0.0816 millimeters, or 8.16 times 10 to the power of minus 2. I need to make sure this is right, okay? 10 millimeters, that would be 10,000 right? I'm not going to change my answer now. If I've made a mistake, I've made a mistake. I'm not cheating, but 10 millimeters to no, let's just do 1 millimeter. Yeah, it's 1,000 times 1,000. Okay, cool. We did that right. Next question. No, fuck. Which statement correctly describes the changes in length in a sarcomere when a myofibril contracts? And the final question is, explain how the difference in glycogen is related to the properties of fast and slow twitch. Oh my god, I don't remember a thing. Okay, let's do the first question first. Let's do the first question first. I hate the muscle contraction topic with a burning fucking passion. Right. We're just drawing this incredibly crudely. So, the hedge zone is there. The I band is all of this. And the A band is and the A band is I don't remember this. I still don't know how you do this. So, which statement describes when a myofibril contracts? Hedge zone decreases, I band increases, A band decreases. So the A band... Oh my fucking god, I don't remember this. Hedge zone increases, I band decreases. I don't fucking remember this. Oh my god. Hedge zone increases. No, the hedge zone is only the... Oh my fucking god, I don't even know the name of this. Myosin. That's actin, that's myosin, right? That's myosin. Hedge band would decrease. Okay? The I band would remain the same. No, it has to... The I band would have to increase. And the A band would stay the same. So hedge zone decreases, I band increases, A band, no change. Head zone decreases. Wait, no, there's no option for that. Head zone increases. No, it can't. Right, no, I'm fucking cheating, because I don't care. If I don't understand this, there's no point in doing a test on it anyways. Right. H band is the myosin. The A band is the actin and the myosin. And that shortens during contraction. Shit. Okay. So A shortens. The I band is the actin. The H band is the myosin. Yes, because I used to remember it by A being all. That's the way I remembered it. A is all. Actin, I don't know. So during contraction, the distance between the Z bands will shorten. Bro, I don't remember this at all. Also, it makes no reference to the Z bands at all in this paper. In this literal exam paper, there is not a single reference to the Z bands. So, okay, H bands is the myosin. I bands is the actin. The A bands are all. So are we saying that the H zone will decrease, the I band will increase, and the A band will decrease? Is that what we're saying? The H zone will decrease because that's only the myosin. The I band will increase because the actin is being stretched, and the A band will overall decrease. No, there will be no change. No, what the fuck? I don't understand this at all. Please give me a definitive answer. Please give me a definitive answer. H zone decreases. A band does not change. I band increases. Okay. H zone decreases. I band increases. Okay. So I had it 2/3 right. But there's no option for that on here. H decreases because the actin slides over the myosin, yeah. I band increases. Oh, but then it says here, or decreases depending on context. So is it literally that both decrease and the A band has no change? Fuck it, we'll just go with that. I fucking hate this topic. I don't understand it at all. I don't know what the fuck the bands mean. I'm just gonna wing whatever. Okay. Fast muscle fibers have a higher concentration of glycogen. And I don't even remember this. Oh, fuck. Okay. Fast and slow twitch. I don't remember. Oh, and thank God, there's only one more question on this. Okay. This is 4 marks. Explain how the difference in glycogen concentration is related to the different properties. So, We already know, we've been given the context, but fast has more glycogen, which means slow is going to have less glycogen. Now, what does that mean? Well, we could probably infer that that means more glycogen, which can be broken into glucose, for respiration, for ATP production, due to high ATP demand. So we know that the fast twitch are going to require a higher concentration of ATP. Now let's actually look at the work here. Okay. Slow twitch have fast twitch have increased myosin. They have an increased glycogen supply. Oh, for glycolysis. Hello. Please don't mind me. I'm trying to remember stuff that I have like no knowledge of. Okay, I think this makes sense then. Fast twitch muscle. I'm just trying to think how you would link this. Slow twitch respire aerobically. Fast twitch require more glycogen because it's a substrate of glycolysis for anaerobic. So, what are the purposes? How does that link to the purposes? Fast twitch have more glycogen because then it can be broken down into glucose. What the hell did I write here? Glycolysin? Oh my god, I'm actually losing it. Slow twitch contract more slowly, less powerfully. Fast twitch contract rapidly and more powerfully. So there you go. Fast twitch is more powerful. More powerful contractions, but more rapid contractions. Slow twitch contract more slower contractions, and less powerful. So, fast twitch has a higher demand for ATP. Therefore, it can respire anaerobically. That should be fine then, no? Surely that would be worth 4 marks. Saying fast twitch has a higher supply of glycogen, as glycogen can be broken down into glucose, which acts as a substrate for glycolysis during anaerobic respiration. This is because fast twitch contracts more rapidly / more powerfully, requiring a higher demand for ATP, therefore it respires anaerobically. Would that be worth a mark? Or explain the difference, Slow twitch will have less glycogen because they respire aerobically, more slow and less powerful, therefore lower ATP demand. That should be 4 marks. Explain how the differences in glycogen concentration is related to the different properties. That has to be 4 marks. That's a valid comparison. You're explaining glycolysis and anaerobic. Bollocks. We'll just go with it. Again, obviously this is a past paper, And I'm not doing the past paper now, I'm saving it for later. I'm just trying to revise the little things that I've forgotten, and it seems very apparent that I need to revise muscle contraction a lot. Oh no, it's a photosynthesis question, of course. This is a graph. What can you conclude about the relationship between the percentage of light absorbed? What can you conclude? Is this on about correlations? The greater the percentage of light absorbed, the greater the rate of photosynthesis. And the colour of light and the rate of photosynthesis. Blue and red lights have a greater rate of photosynthesis as more light is absorbed. Surely that would be 2 marks. Give 3 environmental factors that should be controlled. Do not include features of a plant. Okay. One is going to be CO2 concentration. One is going to be temperature. What's the other limiting factor? Because you can't say light intensity. Rate of photosynthesis. Would humidity be one? I feel like humidity can't be one, but I don't recall. 3 environmental factors that should be controlled when measuring the rate. Could you say soil pH? I remember that one from GCSE. That was a very generic one that you could say. CO2 concentration, temperature, and soil pH. Because those aren't features of a plant. Soil pH. When measuring the rate of photosynthesis and it's controlling, so staying the same. Describe how the products of the LDR are used in the LIDR to produce TP. Do not include RUBP. Okay, cool. So what's it saying? How the products are used. So CO2 is used because it combines with RUBP. I'm sure that'll be fine to say. To produce 2TP. No, at first it's GP. Then the role of NADPH is used to, is it reduce? It reduces the 2GP into 2TP. And ATP produced in the LDR is used. What the fuck? Why is ATP used? No. I should know this. Why is ATP used in the LIDR? The energy from ATP is used to reduce 2GP. So, CO2 combines with RUBP to create 2GP. NADPH reduces 2GP into 2TP using energy from ATP. We've talked about the 3 products. We did mention RUBP. And it says don't include the role of RUBP. But how are you meant to talk about how TP is created if you can't talk about RUBP? That seems a little bit stupid. No, allele quest. Why is this the worst paper? I remember the 2024 paper 1 being the nicest paper ever. Why is this the worst paper ever? Oh, Christ. Okay. Explain how you would determine if the genotype of a greyfly is homo or heterozygous. What? A gene for body colour has a dominant allele for a grey body. So, we are going to have to draw a massive Punnett table here, aren't we? I just know we are. I can smell it. Grey body and black body. How would you determine if the genotype of a greyfly is homozygous or heterozygous? I've never answered a question like this before. How would you determine if the genotype is homo or heterozygous? Is this not something like you would breed it with a homozygous grey, and if any of the offspring would you breed with a heterozygous grey? Then if any offspring are black, that would mean that both are heterozygous. That can't be what it's after. How you would determine if the genotype or is this looking at the parents' genotypes and drawing a Punnett square? What does it want? What does it want? What do you want? I don't know. Okay. I'm Googling this question, which is cheating. Use a Punnett square. That's what people are saying. So, my simple answer would be draw a Punnett square of the parent, of the mother and the father fly. Use this to determine the probability of it being homozygous. I don't know. That is a question which has stumped me, because either the answer is a very obvious use a Punnett square, but that doesn't feel right, or the answer is breeding with a homozygous and determining the offspring. That's all I can think of. To be completely honest, that's all I can think of. Or is this asking for some kind of DNA-related question? Draw a Punnett square to determine the likelihood using the genotype of each parent. I think that that's the answer that it's looking for. In fruit flies, males are XY, females are XX. That's like us. A cross between a grey-bodied male and a black-bodied female produce some black-bodied. Explain how this shows that the gene for body colour is not sex-linked. Right, I need to map this out to figure this out. XX, XY. That's the man. That's the woman. This is a 1-mark question, and we're probably going to spend like 30 minutes on this. Grey-bodied. Explain how this shows that the gene for body colour is not sex-linked. Because both are heterozygous. Both would have to be heterozygous. Therefore, if it was located on the Y chromosome, grey. What? A cross between a grey-bodied male I don't know what it's asking here. I don't know what it's asking. All I would say is both are heterozygous. Both male and female are heterozygous, therefore it can be located on the Y chromosome. Because both... I don't know. What the fuck does it mean? In fruit flies, males are XY, females are XX. I hate questions like this. So, therefore, I don't know. I don't know what this question wants. I don't know what it's asking. A cross between a grey-bodied male fly, so that could mean that it's heterozygous or homozygous, and a black-bodied female, so that means it has to be homozygous. The female has to be GG. The male has to be GG or GG, like that. The male has to be homozygous. It can't be a GG. So, sorry, my answer is the male has to be heterozygous, as it is grey. Female is homozygous, as it's black. So, the fact that they can produce the black children means that the male has to be heterozygous. Therefore, it is not sex-linked. I don't know. All I'm going to put is male is Male is heterozygous, female is homozygous, so gene cannot be on Y chromosome as some children are black. If it was, then if the male was heterozygous, all the children would be black or all the children would be grey. I think I cracked it. I think I figured it out. All the children, right? Let's say that X, 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 Y. If this was the scenario, all the children would be black. If this was the scenario, all the children would be grey. It can't be sex-linked because it's some. That took an obscene amount of time for me to understand, but Jesus Christ. Okay, next question. Oh, you're taking the piss. It's the Hardy-Weinberg equation. I don't know how to do this. I've never understood how to do this equation, ever. We can give it a go, but will I understand it? No. Is it something like this? It's some shit like this, right? %19% are grey-bodied. That means 19% is there. That means 81% are homozygous G. So 81% are GG, 19% are G squared plus GG. What does it want me to do? How many are heterozygous? So, that means GG, so you would square root 81 to get 9, and that's how much G is, so 9. You would substitute in You'd substitute in 81 here. So G... No, this can't be right. G would be 9. So, okay, we would get a mark maybe. Flies heterozygous for G. I don't know where to go from here. %81% a lowercase g. So that means this an individual G is 9. G equals 9. Where do you go from here? Where do you go from here? Let's pop this in a calculator maybe. Because the only other option I can think of would be doing some hardcore algebra, which isn't what it wants. It can't fucking be. B squared, let's just plus B times 9 plus 81 equals 1. Solve. Oh my god, have I got like a syntax error? I've fully crashed the calculator. So I've done it wrong if I've somehow crashed the calculator. Would it just be 9%? $81. I'll just put 9. I'll put 9%. Oh. Maybe that's the answer and I just overcomplicated. Okay. Describe a myogenic stimulation of the heart and how the regular contraction of the atria and vesicles is coordinated. Sorry, ventricles. This is such a bad paper. My god, okay. Well, I have tried my best. We have spent maybe an hour revising over muscle contraction, and that was a hellish nightmare, I can't lie. That was not fun at all. But we did okay in terms of getting through some of it. I now know that I need to revise over muscle contraction. I know that I need to revise over genetics, specifically the Hardy-Weinberg equation. And then in terms of the rest of the paper, it seems to be talking a lot about gene technology, seems to be talking a little bit about IAA, which is that plant practical. I think. And all of the rest. So that's where I'm wrapping up for today, because honestly I'm exhausted after that. That was a draining paper. Oh my god. And we only spent an hour and we got to maybe question 5. So we did get through half of it though. Technically in an exam I would have got half the questions done by this point. And the paper's 2 hours long. So technically, even though I was talking for half of it and I had to go at some point and I wasn't thinking straight, we still were on time, exam-wise, which is really good. So, I'm going to go and I will do this paper I don't know if Paige is coming over tomorrow. I doubt she is, which means I can spend tomorrow revising. And apart from that, yeah. Folk biology paper 2, apparently.